Hello, welcome to tool changing from Mach3. This tool changer is for a bed type tool changer where you'd mill pockets into a table of your router with some sort of drawbar mechanism to pull the tool into the spindle. We're going to start off by kind of just going over the macro and seeing the flow of the tool change and how it's coded. The name of the macro is m6start.m1s. It's available in the Yahoo group as well as somewhere on the Mach support page. We're going to start off by just a real basic overview of the whole thing, and then we'll go through and I'll do a single step run through of the program. Old tool right here. This variable is actually a DRO that I placed on the screen for the tool in spindle. We can look at this. I put it on the settings page. You can see I have tool in spindle. It's pretty simple to put a DRO on the page, and under the OEM number, you type in 1200, and then anything you type in this field, like a 4, will be taken in, and that will be the value for this. And we can demonstrate that here by stepping into the program. As soon as that arrow goes past it, I can cursor over it and old tool equals 4, so we know it's working, and I'll stop the flow of the program. So this gets the tool that's in the spindle, which is our old tool. I did old tool and new tool, and you'll see why in a bit. We also get our positions where the tool change was initiated, because I'm going to actually move the machine back to that position when we're all done our tool changes. Here we get our selected tool, which is actually new tool. This new tool could actually go right up here, but I kind of wasted a little bit of programming and did it that way because I copied that in. We have a maximum tool number. This is used in a couple of places. Most of all, it's actually used in a while loop to actually check to make sure that you selected a legal tool number, and we'll go over that in a second. And then tool down, this is where the Z actually contacts the tool to be able to engage the drawbar mechanism. Tool up is the safe traversing height, which 0 in my case would be the uppermost limit switch, which would be my homing switch because I home positive in the Z. And if new tool is equal to old tool, then exit sub. This is going to bail you right out of the whole tool change so that you don't waste any time. And then we have while new tool is greater than the max tool number, we fall into this loop, and it asks us a question of enter a new tool number up to, and then it displays the 8 instead of this here. It'll keep asking you that question until you give it a valid answer. So that'll be kind of nice because you won't stuff any tools. Now here we have a G0, G53Z tool up. This looks very similar to a normal command line that you type into like MDI. And it's very similar. All you do is you type code, and anything you literally want it to do, you put inside your quotes, and then an ampersand and the variable. So this will actually read when it's all done, G00, G53Z 0.0. And that's our safe traversing height. So it goes in, it makes sure it's at the safe traversing height. It waits until it's all done, the move, and then it will let it go to this next thing. This next thing you'll see is a call. Well, call is we're calling a subroutine, and the subroutine is named move position, and we're passing it the old tool value, which in our case is 4. So we come down to here, and we can see we have a sub move position, and it's passing it the tool number. You'll notice they're not the same thing because this is a subroutine. You can have anything you want down here. It's almost like its own little program. And what we have is a case statement. So the tool number comes down through and it gets checked. Is it tool 1? Is it 2? Is it a 3? Is it a 4? Is it a 5? Is it a 6? And so on and so forth. And then if it is this, then set X position and Y position to these values. So what we have here is basically an array of values. It's not actually an array, but we have a bunch of values that say, okay, yeah, this is my position for tool 1, this is my position for tool 2. So any custom tool changer can be modified to use this code because you can type in your values here. For other tool changes I've done in the past, I'd actually just write a quick little algorithm and just use mathematics to figure out where the positions would be, because it had some mathematical relationship. But this one, you could have 8 totally separate positions, and if you need more, you can copy these and paste more of them on, and you could have up to 200 and something if you'd like. So you can run a very large tool changer with this very easily. At the end of this code, here you'll see code G53 X position Y position. So this will move us to these positions, and then it exits and it goes right back up to where it started. So that break there basically just moves us into whatever tool position we ask for. So it makes the code a little bit easier to run, but it's very important that you understand what it's doing, because that's where you edit your tool change positions. So it waits, it moves the tool down, and then this G4P.75, we're actually pausing and waiting for it to be into place, and just kind of wait for 3/4 of a second. Here we have an activate signal, output 1. This is going to activate the signal to release the drawbar mechanism. And once we've released the drawbar mechanism, we're going to wait for a second. And if we did have a limit switch, we could put system wait for to guarantee that it is released, and it will wait there until that state changes. But we don't have one in this case, so we can't use a wait for. And then we have a code to pick the tool up, move to the new position of new tool, and that means we're going to call that same function we had done before. So the new and old use the same subroutine to figure out where to go to change the tools. We move down, wait for 3/4 of a second, guarantee that all movement is stopped, deactivate the signal, which means we're going to clamp onto the tool, and then pause for 1 second, pick the tool up. We're going to set the user DRO 1200 to new tool, which is our tool in spindle. So we update that to tell it what tool is in the spindle now. And we set our current tool to new tool, and then we do a rapid back to where we initiated our tool change. So that's how the tool change code runs, and if we want, we can actually scroll through it step by step. The only thing I'm going to do before we do go through and run our tool changes, I'm going to give this like a tool 6. That way we can see a little bit of what it's going to do. And remember that we have a 4 in this one, which I'll show you how you can check that. We do a mouse over and we can check the values that are coming in. So we can just go through line by line. We can see that when you move to X, Y, 0, and Z, it's because I'm in that position. And our max tool numbers. And if I slide this down, you should be able to see my DROs change as I scroll through the code. I'll kind of bring the bottom of it up so that you can see what code it's trying to run. There. So this is how I test all my code. So we're going to move to old tool. And if we turn on our machine coordinates, it's checking the case to see what tool we've asked for, and we've asked for tool 4. So we go through that, and now you'll see it move into position, and it jumps us back in. The tool goes down with that code, and we're waiting. You saw the LED over here flash for the pause, and then we're going to set our output, and then we're going to wait. You saw that flash again. Now we're going to move our tool up, and now it's looking for the next tool, and you can see it didn't actually find anything. That's because I didn't do a real tool change. It didn't pick the value out, so it went back to the same position. This won't be a problem when we actually run the script. It's because I didn't have an M6 actually activate it, but we can test to make sure that everything else is working. You can see it went back down, it paused, it deactivated the signal, pausing again. We're going to do a tool up, and then we're going to set our DRO. We can check that in the offsetting, so it's going to set it to 0 because that's what it thought it picked up, so that did work. And we'll jump through one more time, and one more will return us back to our position. We'll swap back to main screen so you can see it move back into position. It should be all zeros because that's where we activated the tool change, and it did. So the tool change works, and that'll end the program. So hopefully that gives you a little bit more about it, and if you want, we'll actually run a tool change real quick with this script. We'll save it and close. And to do a tool change now, we just need to make sure that whatever tool is in the spindle is here. So we have tool 5 in the spindle, and if we do an MDI input, we can just say M6T4, and it will now go to different positions and do a tool change. No, it didn't do a tool change, so we must have something in our logic. Ignore all tool changes, so we just want to set that for automatic tool change. That's why it didn't work. And if we rerun that, hopefully we'll see something happen. Okay, now you can see it move into a position. It's dropping down. It's waiting. It picks up. It moves to a new position. It comes down. It waits. It clamps. And then it will pick back up and then move right back into its original position.